started except for YouTube. And YouTube has started as well.
All right.
And we are live. Ooh, congratulations. Okay. Cool. Hi, Adrian. It's
Hey.
nice. Thanks for coming to my little show, I guess, now. I wanted to talk to you about UI frameworks a lot, and I know you watched the previous stream with Raf Levin and had some interesting questions and probably some opinions as well. You also wrote Membrane, or are writing Membrane, which is a UI framework for Clojure. Pretty interesting perspective. So yeah, I'm excited to have you. I don't know,
Yeah,
where do we start? Yeah, sorry.
yeah, I'm excited to talk to you about. I know that it seems like your intention is to build a UI framework in Clojure. I'm excited about that because one, it looks like it's not going to be built on top of React, which I think opens a lot of design space and there's a lot of interesting opportunities. I think basically anything that isn't built on top of React, I think there's a lot of design opportunities and a lot of cool things that are possible. My library Membrane tries to capitalize on some of those, but there's lots of other options that I didn't try, or uh, there's lots of other ways to go about it that I think would be interesting. So I'm interested to see what you come up with, and yeah, it's basically where I'm coming from, and also not trying to build a functional UI framework. It's been tough kind of finding other resources for. I mean, there are a few other resources, but there's not as much kind of written about or talked about what that looks like. Like if you look at some of the other typical functional languages like Haskell or Elm or uh, yeah, there's a few other ones, but they don't necessarily write a lot about how to kind of build a UI framework from scratch. And yeah, so I'm excited to see, and it looks like you're kind of taking a really interesting approach. So excited to see what that looks like.
Can you tell about how did it started for you? Like, how did you decide to build the UI framework? What's the idea, maybe?
Yeah, so the basic thing was, I was trying to build something. It's basically kind of programming for non-programmers, and it was a tool, and I wanted to build it in Clojure, and I started trying to build it, and I just felt like I just kept, and the way I approached it is like I was familiar with, at the time it was in Ohm, which is an old Clojure script UI library, and I was building that, and I just kept running into issues where it was really difficult to build the product that I was trying to build. And basically, what I wanted to use the power of the JVM to access a lot of libraries, and I built the user interface in the browser using Ohm, and then you kind of just run into these issues making this kind of like distributed application. And I was doing a lot of um, custom UI stuff, there's a lot of state that went along with it. And yeah, the whole system seemed overly complex. So I took a step back to try to think of like, okay, if I really wanted to build this the way I wanted to build this, what would that require? And that kind of led to Membrane. So, um, and now I'm finally getting kind of back to the point where Membrane is at the point where I can start building the things I want to build in Membrane.
Nice. Did it came up as a part of some bigger project, or is it like fun project for you? Or
Yeah, it's kind of a passion project. And eventually I still want to kind of get back to the tool building that I was doing before, where it's kind of in the similar spirit to um, uh, Portal and Reveal, but hopefully with more. I think there's still a lot of opportunity there, and I think if it was a little bit easier to build applications, I think there's you can raise the bar quite a bit. And so that's what I'm looking to do eventually, once kind of membrane is more stable, to build those applications that I think are possible.
Cool. But like, I wish I could. I had something to argue, but like, I agree with all your points. I independently came to the same conclusions, mostly that I want a single application or distributed application, like not a web UI that talks to a server. Just by having it in a single VM, it's so much simpler. It's like almost trivial how easy to write UI, and yeah, and being on JVM, I don't know, functional. Maybe we can talk about the concepts behind membrane. I probably want to ask you as a question that you asked us last time at the end of the stream, and I find it in your blog as well. You ask it yourself a lot. What is UI?
Yeah, I mean, so one of the things is I've been building user interfaces for a long time, most of them on the web, but I've also been working at games where you can kind of where it's a different approach to building user interfaces. And I've always felt kind of, especially on the web, that things are more complicated than they had to be. And I really wanted to dive deep and answer that question for myself. Like, is it really, is like all the stuff that we're doing on the web, is all that complicated necessary, or is a lot of it incidental? And the more I work on membrane, the more I think that like most of the stuff for UI programming on the web is incidental complexity. It's stuff that's kind of just you run into all these issues that have nothing to do with the problem you're actually trying to solve, and there's a lot of wasted time and effort. I think still to this day, I mean, it's hard to keep up because there is a lot of there are improvements happening and there are new libraries and approaches, but for the most part, you have a designer who will kind of do the whole design in some sort of program, and then they will hand that over to a programmer who will like then redo it completely, in some other thing. And so if then the UI designer makes a small change, it can actually require big changes from the programmer side to kind of re-implement it. And so one of the design goals for Membrane is to kind of be really thoughtful about how UI designers and programmers kind of, because at some point they need to work together, and there needs to be a point where they're like, where they meet, and to be really thoughtful about like, okay, what's this whole workflow? Like having somebody create a Photoshop file or Figma or Sketch, and then like having that completely re-implemented on the other side just doesn't make any sense. And so going back to, so for building a UI library, it's very much like step one, define the problem, and before you do anything else. So one of the questions that I try to spend a lot of time on is like, what is a user interface? Like, what is it kind of set apart from like all of the technologies that we're using? It's like, like for when we program generally in Clojure, what's nice is we have all these abstract data types. There's like, maps, lists, vectors, strings, numbers, and all of these things are kind of separate from like, in some ways, the abstract notion is separate from like the implementation on the JVM or in JavaScript, which is one of the reasons why I think Clojure has been so portable, is because they're built on these like abstract notions that are true regardless of whatever kind of like technology is popular. And I think trying to think about it the same way for user interface, like what is it at its, like what is a user interface basically? So, and I look at all these other UI frameworks, and it's been really tough because it's like there are lots of options for building user interfaces. There's lots of libraries and frameworks, but it's been tough finding any library that will kind of explain upfront, like, okay, here's, define the problem. What is a user interface? What should it do? What are the building blocks? What are the primitives? So I've tried to answer that for myself. I don't know if, I mean, you've worked in user interfaces for quite a while. I don't know if you already have a sense of like what you think a user interface is. Love to kind of hear your take before I kind of like pollute your whatever your intuition is with what I've come up with, because I'm not sure what I came up with is actually right. I'm trying to find that answer.
No, I did work with user interfaces a lot, mostly with web. I haven't really worked with native UIs or mobile UIs really. I think like from the start of my career, I started with web and like it was all web. We did web application for mobiles, but it was still web technologies. So, and I also bet at abstract questions. Like when somebody asks me abstract questions or theoretical questions, I'm kind of bad. But to best of my ability, I'll try to answer that. So, user interface is a way to between a person and a computer to communicate, right? Some way to build this two-dimensional communication. So user tells commands, computer gives you information, and this is a loop like continues. But yeah, maybe I don't know. And this is from like I don't know, philosophical point of view, right? If you are asking something more concrete, like how should it be implemented, something like that, I think there are options.
Yeah. So for like, I mean, the kind of the approach of, well, I mean, the other thing that I've tried to do with Membrane is that I don't necessarily think we have good vocabulary to talk about user interfaces and the actual kind of differentiate what the important trade-offs are and what the actual kind of like primitives that we're using. So with Membrane, I've tried to come up with kind of terms and define them kind of more specifically, because there's a lot of like component. Well, what's a component? And especially, you see this a lot with MVC where like, oh yeah, there's a model view and a controller, but there's not necessarily a lot of agreement what each of those things are. And if you talk to different people, like they're going to have, you say MVC to 10 different people and you might have 10 ideas for what that actually means.
I remember, like, sorry, but if the COPCK, it's interrupting. Regarding MVC, yeah, it's actually crazy because like there's this abbreviation MVC, which is cool that everybody agrees that there is something like some conceptual model, and then everybody understands different things under what is M, what is V, and what is C. And I think even on Wikipedia there are like MVC1 and MVC2 or something like that. Like there are two different interpretations of that. Yeah, it's completely crazy. I don't think this explanation explains anything or helps anybody. Yeah, I agree.
And yeah, so for Membrane, basically, I mean, I think the definition that you give is basically the same definition that Membrane uses, which is like you have a person and you have a computer program, and in between them is the user interface. And so like the one important part is that like the user interface is actually not the program itself, and that you can separate, at least separate it from the program, and so that it should be hopefully simple in the sense that you can extract it from the program. And I think one of the design challenges with user interface programming is that it tends to swallow your program, where like, you're building a user interface and there's no separate program. Like you can't run the program without the user interface, and like you can't, unless it's connected to all the graphics and events going on, like your program doesn't do anything. And I think it's a design problem that we should work on. And so it's between the user and the program. And so from the program to the user, the main way for the program to communicate its state is through graphics. That's how we build it. But conceptually, at its core, the user interface has multiple options for communicating to the user. It's just that graphics is the primary one, but all of the concepts from a kind of like a model perspective should apply for any type of other output. So like sound, haptic feedback. I don't know if you like wanted to produce smells or something, but basically like, any, you should be able to theoretically like have a user interface that has other outputs besides just graphics, but that's what membrane focuses on for now. But a lot of the machinery would also work for sound or for other outputs or like haptic feedback, like, when your phone vibrates when you get a notification. That's another example. And then from the user to the program, the main inputs are mouse and keyboard, but all of the event stuff in membrane is it's like a generic event system. So if you want to add a joystick or touch controls or other types of events, like mouse and keyboard aren't special. They're just like one class of like ways that the user can communicate with the program. And so you have this two-way communication, and basically membrane tries to like say, okay, at the bottom, you have two functions. You have, we'll kind of just like say, I like to boil it down to basically graphics and events. So graphics is the output, and the events are the input. And so you have the view function, which takes the state of the program and figures out what to present to the user. And then you have the event function, which takes any sort of raw input like a mouse keyboard event and returns the intent of the user. And it's really important in membrane that the effect system, the event system is not based off of side effects. It's it actually has a return value. So you can say like, your view, your UI, you can ask like, okay, if I click at X coordinate 6 and Y coordinate 222, it's just a function. You give it the input and it'll return the intent of the user, which may be like add a to-do to this to-do list or delete something or send you an email. And so the idea that the event isn't based off side effects, which is what most UI frameworks do, it's based off of return values. It's just a function. So membrane boils down all of like the whole UI model to the view function and the event function, and everything, all the stuff that membrane provides is really just just tools for building those two functions and making it easy to kind of, because you want like a user interface that does a lot of stuff that we like using today. And so it's really just about building those two functions and then being able to hook those two functions into with different platforms. So so using those two functions, you can define a user interface that's kind of separate from like all of the technology and just like a model. It's just data. And then like one of the cool things that I think shows that membrane is I think one of the cool features of membrane is that you can define a user interface and it'll run on mobile, it'll run in a terminal UI with mouse and keyboard events, it'll run on desktop, you can have it spit out WebGL, and it's because it's all just based off of this model, which doesn't have anything to do with like the model is really just describing what the user interface is, and not necessarily like in terms of like divs or UI kit views or very specific technology concretions.
Okay,
I rambled for quite a bit.
No, yeah, sure. It was good. I have a few questions about what you said. First would probably be first of all, I think you did a great job boiling down the UI to the absolute minimum. This view function and event function, right? like there's the two functions. One generates the UI, and the other one modifies the state. And it's excellent. I probably still, and the idea about returning the events from the components, like not side effecting but returning them back, it's actually also great, and it's very functionally, and I will probably try something like that as well. I like that idea very much.
Yeah, I mean, just say that the event function doesn't modify state itself. It tells the program, and I mean, in a lot of ways, the code looks similar, but it makes a huge difference in practice for like debugging, development, and all these other areas where like, I mean, I think that's one of the reasons why UIs tend to absorb your application is because they have side effects everywhere. And so side effects mean that like they have side effects, global state, hidden state, and all these things make it hard for these for stuff to be reusable.
It doesn't modify it. It takes like operating system events and converts them to intents, right? Something like that.
Yeah.
That's the idea that I want to steal. Yeah. So first thing that I probably am interested in, so your view function, the way you define a view function, it's something that returns some sort of DSL, right? It's not like objects. It's just like description of UI. It's not actual views, so to say.
Yeah, it's just so I mean, like I kind of repeat myself a lot about this, but it's basically data and pure functions. And I think like if there's one takeaway, it's that from all of this is that where we could be building user interfaces out of just data and pure functions, we're not, and we're suffering for it. So that's the whole like, and so for the UI, you have the view function, which returns a view, which is just data. And I think, so there's kind of two things I would say about that is one, I'm not sure that the data or that I mean, there's lots of options for how you model the data that describes what you should kind of draw to the screen. Now, I'm not sure that I think that's an area where I think there's still room for improvement, but I still think that it's like, after having used it for quite a while, it's still much better than the experience that I had working with the DOM and like HTML, CSS, and JavaScript for describing kind of graphics. The divs and spans and all of the CSS, HTML, CSS, and JavaScript was really hard to like, okay, here's what I want it to look like. And then I like go to like do that in HTML, CSS, and JavaScript. And it's like, it's like a puzzle, which can be kind of fun, but it's, if you're really just trying to like build something, it can be quite annoying. And so what Membrane has now is basically, it tries to use primitives that are familiar to designers. So there's like shapes, images, text, 2D transformations like translate and scale. There's fills and paint and strokes. And so I think kind of I picked at the time things that kind of made sense, but I think probably if you were going to improve upon it, I would really start with kind of the strokes and paints. I mean, I would look at the design tools and see what kind of primitives designers use for building user interfaces, but there's like the strokes and paints. And then I would also try to do a better job of basing primitives off of 2D geometry, basically, for 2D user interfaces. Because now that I'm starting to build more complex user interfaces, it's like, oh, I want to be able to do intersection and I mean, all the stuff that you have in 2D geometry, like find points that are like tangential to or parallel to or orthogonal to. And, if you use just a 2D library at the bottom, you get like a whole lot of benefits. And I mean, one of the benefits, I mean, so far, I think there's room for improvement with the 2D geometry math part, but even just having shapes, rectangles, paths, polygons, text, images, as data gives a lot of provides a lot of huge benefits within membrane because it's all just data. So one issue that I found when I was working with other UI technologies is like you get a lot of very specific, it's like you can't have a debugging library. You have like a debugging library that works with this specific UI framework, where you have like, you can't just use state management, or you use state management that works with this specific UI framework. And everything becomes very specific. Whereas if you kind of use data and pure functions, like what debugging library do you use? Okay, well, what do you normally use? If you're using, if you're writing an event handler, what do you use? You just use regular Clojure data stuff. And so you just get a whole lot more reuse because it's all data and pure functions. Clojure has a lot of libraries that work with data and pure functions. And so you can, you don't necessarily need a specific state management library. You just kind of, you can just reuse other Clojure libraries. That's why I'm excited for what you're working on, because I know that if you build it on top of data and pure functions, I can reuse all that stuff. If you look at UI libraries that are commonly available, it's like if you have a calendar widget written in framework A and you're using framework B, like you just can't use it. It's not reusable. You have to rewrite your calendar widget. Even if it's like even if they're both built on top of React, a lot of times you just can't reuse it. With Membrane, one of the things that I'm excited about is that there's like one function that turns any Membrane component into a reframe component. And there's like one function that can mechanically turn any Membrane component into a Fulcro component. And so all of the Membrane components, they're just pure functions, and you can reuse them in other UI frameworks, because if you're using data and pure functions, you get that that's part of the flexibility that you get. So I'm hoping that you build a bunch of cool stuff and I can just reuse it. So.
That sounds very good, and hopefully, more frameworks join it. I'm confused. I thought for some reason that the stuff you return from views is something like hiccup markup, like keyword button, keyword label, stuff like that. But I'm looking a lot now at membrane/UI, and it's actually records, right? So you return more like records that implement some protocols. So it's not. What do you mean? So when you say it's just data, it's like more like objects, I would say.
So it's records are just kind of like basically they're basically maps, except for one of the things that I'm experimenting with right now is trying to take that even further and to use just the kind of built-in Clojure data structures. And what's cool is that like you said, there's these protocols. So I can just implement these protocols and make it work with maps and vectors and regular Clojure data structures. And so as long as, it's kind of like the data structures in Clojures, right? Like in Clojure, there's the sec library, and there's also, I have protocols for associative data structures. And if you implement those, you can create a new type of data structure with different performance and different trade-offs. And you have this giant library of sequence functions that works with your data structure day one. And there's a lot of generic code that just works on sequence functions. And you build a new data structure and everybody can just use it day one. So there's a lot of, and there's also, there's kind of a similar thing. I do think I would be interested in seeing if there's a way to take that even further because there are some things with, so records were kind of a more popular data modeling option in Clojure kind of a few years ago when I started. And now, there's a lot more support for just using plain maps and vectors and the built-in data types without records. So, I think that is like an interesting area, but even today with the records, it's like, okay, well, what's a rectangle? Like you don't need to know. It's just, there's multiple ways to define it, but basically, you have 2 points. You can define it with 2 points, or I guess a line is easier. A line is 2 points. And so there's actually like so in membrane, there's a path, which is a set of points, and you can kind of connect all the points. And that's really just data. So like if you have that path and you want to write it to a file and somebody loads that file later, like, just the set of points, they can reconstruct the path and do whatever they want with it. They can use it. If you send it over the network to another language, like, like a path is just a path, and you can, it's usable from another language. A lot of the, obviously, like a lot of the stuff that draws it is tied to a specific platform. But if, you wanted to create a new, there's basically like, for the most part, it's kind of fun to implement a new I call them backends for membrane, where like, okay, it's running on desktop. Okay, I thought it was a fun project to take it and make it run on my iPhone. And basically you provide implementations for like, if you can draw shapes, text, and images, and then forward events, so you're basically like, that's basically all you have to do to implement a new platform. And it's like, okay, all the stuff runs now on a new platform. And I think it's because like, a rectangle has meaning. Like, you can just represent the rectangle as data. And as long as like there's something that knows how to take a data representation of a rectangle and draw it to the screen, you're like ready to go.
No, yeah, I absolutely agree. It's very worthy goal, and yeah, I was looking at different implementation details and how you swapping out backends looks like. Yeah, looks like that the protocols are great for implementation. Like if you provide one implementation for all platforms. And for drawing, when you want to swap in and out platforms, you use item with list of functions, I suppose, something like that.
Yeah, the protocols are like, the main ones are kind of getting, like, this is why I was kind of mentioning the 2D geometry. A lot of the protocols are like around the 2D geometry. Like, it's all the stuff that you learned in school about geometry. It's like, it's the bounds of the element, which right now there's only one function for kind of the rectangular bounds, and it's a little bit overloaded. I think that's one improvement, is to like, instead of just bounds, you have the rectangular bounds, you have the there's like, you can create a convex polygon for any shape that kind of encapsulates it. There's different ways to kind of, there's different kinds of bounds that people might be interested in having different functions for each one of those. But what's interesting is that like, if like you have hiccup representing HTML, there's no way to ask like, okay, how wide is this? What color is it? What's its bounding box? And unless you kind of like hand it to a web browser, plug everything in, and like write some JavaScript, it's very difficult to get those answers. But with, a lot of these things, it's like, well, what's a rectangle? How wide is a rectangle? It's like, it doesn't depend on if you're running on the desktop or in the web or wherever. It's like a rectangle's, it's the same. And so using kind of primitives that like basing on 2D geometry makes it's like you can have the model in so a lot of these the 2D pieces, there's one implementation that kind of works on all the platforms. There's multiple drawing functions because there's a lot of different ways to draw a rectangle. You can use it, you can use the Canvas API. You can, in terminal, you spit out these like ANSI codes. There's multiple graphics libraries, and you may actually want to, for specific use cases, override the draw function for a particular element for performance, where you can like text is a big example where when you draw text, you don't necessarily want to draw each character each time you render some text. You want to like draw it to a like a buffer and then reuse that buffer as long as you're getting that same text, because otherwise it's slow.
I mean, ideally, I would agree with you that measuring should be platform independent and like it shouldn't require you to fire up the whole Chrome and etc. But kind of measuring stuff is actually platform and implementation dependent, right? Like measuring text, especially. Maybe not rectangles, but text is hard to measure. So how do you solve that?
Yeah, that is right. So that's one of the things that I'm not. I don't know if I have the best answer. The way it's currently implemented is that you can kind of like. I mean, ideally, I mean, a lot of these. I mean, there's a couple options. I mean, since there are a lot of text rendering libraries and they all kind of do their own goofy thing, ideally, if you have a font and you want to render it, it should be at least pretty similar on multiple platforms. But you do run into issues there right now. Like what happens is basically like when you load a backend, it also comes with a like it also kind of implements the function for what size the text is, and so you can't measure. There's like one that's built into the JVM that it will use if nothing else is available, but so usually there's basically a stub for measuring text, and it gets overridden when you do a backend. And the reason that kind of works is because for the most part, you're not using multiple backends. And in fact, some of these backends are incompatible anyway. Like if you try to load Swing and like there's a Skia backend that uses GLFW. And if you try to load both of those at the same time, it'll crash. So some of these backends are incompatible anyway, because they're both talking to the OS, and the OS they're both trying to talk to the operating system, and they're not coordinated, so it'll crash anyway. So in practice, the fact that you pick a backend and that backend will like insert the text measuring it, like all the functions you need to measure text. It's ideally you would just have like a library that like looks at the TDF file and like can do all this stuff for you, but I don't have that right now. So yeah, that is an issue. I don't know what the answer is.
That makes sense. Yeah, no, it might totally make sense. It's probably, I think it is going to be always platform dependent, I suppose. The functions that draw text should be the same exact functions that measures it. Otherwise, there will be issues. So like, I don't think there's a way around it. Unfortunately, I wish there was. I wish it was like more. It would be more pure if you could measure text without drawing anything or requiring drawing backend. Or yeah, I agree, but that's unfortunate. Okay, so there is a question in chat about the animations. Like, how do you do animations if your UI is just pure function of state?
Yeah, so like there's I mean, there's a couple of different ways to do it. So like one of the, so the goal is to kind of simplify things. And one of the benefits you get is that it's more flexible. But what that also means in a lot of cases is that you have more options, which can, sometimes you just don't care. You just like want a good default. And so with membrane, one of the things that's annoying about the web is if you have a non-standard use case, basically there's like this default, but you can't there's no real access to kind of like the core loop that does the drawing and handles the events and like what that loop looks like and whether it's multi-threaded or not. You don't really have access to that. You have hooks where you can like request animation frame or set timer, or like there's different ways to get onto that event loop. And you kind of have to like poke at it from the outside. So with membrane, you can construct your own event loop. And a lot of these performance, for like good performance, you want control of these kind of like simpler pieces, and you like being able to control the event loop makes a lot of sense. So you have options for kind of like actually building the event loop you want. And depending on, like there's a difference between, like, okay, I'm going to animate 10 things. I'm having a small user interface. You touch the hamburger and stuff slides up, and stuff will like slide in and out, or you're building like a PowerPoint presentation type software. And it's like, okay, you have like a handful of animations on the screen at once. That's like one use case. And then you might have another use case that's more like a game where you have like 10,000 sprites and they're all like sparkling and jumping and moving around. And that's a different use case. And so, what's good for one may not make sense for the other one. Like, and so you have the option of kind of like picking an implementation that matches your use case. So the defaults right now is that, so sure, yeah, you have these options, but like most of the time you just want good defaults. And so the default is really I think this is an area that could be improved, but right now, basically like Skia draws things really fast. So I haven't run into any bottlenecks with animations. You can basically just like redraw everything every frame, and it works well. It consumes the extra battery, which is kind of a downside, but there's I think that's an area for improvement. As far as like defining the model, there's a couple different ways to. That's something I've thought about, but haven't for the use cases that I've targeted. It hasn't been necessary, but I've thought about a few different ways that you can go about it in a very functional way. So if you look at, so like one inspiration is if you looked at Swift UI, they do have kind of like these built-in animations. And they also have a pretty functional data-oriented way to build views, as far as I can tell. I haven't used it for a big project, but just kind of going through their docs and looking at what they've written about it. Basically what you can do is you have a view and you give it an identity. And then if you then kind of the next frame gave it another view or return a view with the same identity with different properties, it'll automatically interpolate between those two. And so that seems like one pretty good option for kind of user interface where you have a handful of animations on the screen.
I think I saw it in effect. Like sometimes it basically what it does is automatically animates like without your interference. You just specifies that end state is now this, and it like automatically builds an animation between two states. And sometimes it produces very cool looking results, like everything is smoothly like when you switch from one screen to completely different screen, right, but kind of with the same components or maybe different view of the same stuff. and it all flows like where it's supposed to, and it's pretty cool. And sometimes it like does crazy stuff, like the stuff that shouldn't be animated really, but because it's like also label, for example, so text like kind of changes from one text to different text, so stuff like that. So sometimes it's good, sometimes it's fun. Yeah. So, but I think I saw it. Yeah.
Yeah, and like I think one other kind of piece of that is like if you return kind of largely the same data every time, you get a lot of benefits of like caching and memoization. And so like with animations, basically you have stuff, you have some variable that is going to change every single frame, which kind of like will invalidate all your caches every frame. And there's a couple of ways around that. So you can either say that it's okay to pay that price, and for some user interfaces, that's a really good option because it simplifies your code. Everything is more functional. And then another option is basically kind of a similar thing to the Swift, where you have, I mean, a lot of the graphics stuff and the performance stuff is basically you have this, you're just trying to draw stuff every frame before in like your time budget. And so you can have it, you can have your event loop kind of efficiently, I'm trying to think of the right words, but basically like usually you have like a lot of these animations are defined 0 to 1. And so it's like it's transitioning from here to here, and here's 0 and here's at 1, it's done the full animation at the full time. So you can have these animation counters kind of done, provided for you by your event loop in a way that's efficient, so that basically you're returning the same view every single time, because this, but you're saying that the position is dependent on a frame variable that will get updated every single frame in an efficient way. And so you still get a lot of the benefits of like caching, because you're returning the same view, but the only thing that's changing is this, when you draw it, when you draw this, when you draw this box that's moving, its position is dependent on this frame variable, which is like, and so as long as nothing else is depending on that, then like you can do this very efficiently and you get a lot of the benefits. A lot of games do this, where you have like effects and sparkles and stuff that like it doesn't have any effect on the game, so you can just draw like a million of them because you can do these all these things in shaders. So there's different options depending on your use case, but that's maybe one way to think about it.
Okay, so another question probably related to that. I think it's probably related. So did you run into any performance problems? Do you feel that it will be not necessary, or are you just postponing these decisions? Because like pure view from data is great. Re-rendering on each frame is also great, but like, can you like at some point you'll probably need to optimize, or do you think you wouldn't, or what do you think?
Yeah, so kind of initially, like I just wrote, so unfortunately the membrane has a pretty large surface area. It's like, I wanted to build this library. It's like, at the time there wasn't this cool Skia library. So I had to like write my own integration to Skia. And, there's like, there's a lot of, there's nothing that worked with GLFW. So I had to write my own integrations for that. And like a lot of the stuff on the JVM for doing graphics, there weren't necessarily good options. So it has like a pretty big surface area. And so what I started out doing was just kind of like writing very straightforward closure implementations. And from that, I've like, one of the takeaways is that I was like absolutely shocked at like how little I had to do to make user interfaces feel good and have really good, really low latency. And I think part of that is like, and now even like I'll be working on my working on desktop stuff, and then I'll go to the web and like everything kind of feels janky now, where that I didn't used to notice before. So I don't necessarily think that the web is a good benchmark, but for a lot of people, the web is kind of like what they're used to. So if like, I mean, you get a lot of huge wins in the fact that like you're not transferring the whole application over the network every single time you load the UI. So that's, that's a little bit cheating because you're doing less, but there's a lot of stuff that like I've been really surprised at how responsive everything feels, and some of that you get from so like I have spent some time like optimizing some things. So like the foreign function interface calls to the C code that does the graphics. Like, if you're drawing stuff every single frame, having just the, spending a bunch of time just making the FFI call can eat into your budget. And then the other big thing is caching, which when you're using, if you have immutable data, a lot of stuff on the screen just doesn't change in between frames. And so with object-oriented stuff, a lot of times it's like, if you change a property, it'll like go and redo a bunch of stuff, and then you change another property and it'll like recalculate stuff and like do this mutable dance, and React, to kind of try to counteract that, tries to like batch things and do properties and like read stuff in like specific orders to like not trigger layout re-renders. With immutable data, you kind of, if you just do memoization where you kind of like, each frame cache, use the cache that was from the last frame, you get a lot of the same benefits for free, where you with a lot less code, because it's just, you just say memorize this function, and you get a lot of those same benefits. I do think, performance is like a really important issue, because for every single UI framework, having it feel responsive is a feature, and you're like, a user interface that is more responsive is just better than the same user interface that's slower. So I've been surprised at how little I've had to do to kind of have user interfaces that feel responsive. I do think, I think there's a lot of what's cool is that there's still a lot of there's a lot more work left on the table that can be done to make it even faster. So some examples of that is, for the most part with drawing, there's very little, Ski is actually pretty performant, and it does a lot of work for drawing drawing the graphics pretty quickly. One of the, like, if you look at how Chrome renders stuff, basically it'll like, basically it segments the screen, and like it'll try to figure out like what's the minimal amount of drawing it needs to do based off of like the new user interface. And there's a lot of right now there's only a little bit of caching of draw calls in Membrane provided, mostly around text, because text is the one where if like you're drawing every character every frame, it's going to be super slow. But and the same thing for images. If you're like decoding a PNG image every single frame, it's bad. But I think that is an area that could be improved. And like one of the cool things is that like, you're turning the data into draw calls, and kind of figuring out how to like redraw stuff and minimizing draw calls. And I think a lot of that, this is just compiler stuff, and you can kind of reuse all of that across backends. So I think that's a cool idea, in the sense that like, maybe you're like, I have a Raspberry Pi, and you can get these like little tiny screens for your Raspberry Pi. And if, let's say you wanted to make a backend just for that screen, like you want to like reuse all of your Membrane stuff, but you want to target this new platform, having all of the draw call optimization code available to you means that you can implement that backend, and you get all these optimizations, or you can like have access to all these optimizations for free, especially on a platform that may even have more benefits because it's slower to begin with. And then so that's like one avenue, is like optimizing draw calls. The other avenue is that kind of what I'm working on right now is trying to define. So there's a data format for saying like, here's the view, here's the graphics and event function, and kind of trying to build a data model for the UI components. It's the UI components more generally. And what you can get from that is basically you can take the description of your UI tree, you apply the same kind of, and right now that what I'm working on is it's kind of like an AST, and it's basically kind of just regular, like a lot of the compiler technology that you can just reuse. Like you have basically a description of your program, your UI, the UI part of your program, and you know which parts are dynamic and which parts are static. You can actually spit out code that removes the, if you know things are static, you can just use like the regular compiler tricks to spit out an even more efficient view function and a more efficient event function because you already know which parts are static and which parts are dynamic. And part of that inspiration comes from a JavaScript library called Svelt. I don't know if you looked at it. There's a lot of really cool ideas there. And they also, theirs is a little bit more based off side effects, but I think they're a really good example of taking this like compiler approach where you kind of define your component. They do it using like JavaScript. And they'll kind of like take that description and compile it. I think, the closure approach is like, or in my mind, the closure approach is you define these UI components and as data, and basically like as an AST, and then you can kind of like spit out a just the event function and the view function based off of that description using compiler, it's kind of like similar, like when you use ClojureScript, it uses all this advanced compilation techniques to kind of like make your code more performant. And I think we could, if you have a UI description, you can kind of do that, but with more specific optimizations for like, a lot of the stuff that you're doing in user interfaces, like, there's a lot of stuff that you can share and kind of have specific use cases for. It's like a lot of the stuff is like, okay, I'm clicking here. What's under that? What's under the mouse when I'm clicking? And so, especially if like, if you're defining all these things in like rectangles and shapes where the sizes ahead of time, in a lot of cases, you can build an efficient data structure ahead of time at compilation time that says like, okay, when you click here, here's the binary search to like figure out what thing is under it. And you can do that all at compile time because you already know ahead of time that like what's going to be there for the most part. I don't know if that makes sense, but like basically I think you can do all of these things. Having the data description means you can do a lot of these optimizations at compile time and have even faster code than you would produce if like, like you're doing everything at runtime.
Yeah, absolutely, and it's probably even easier to do in closures than anywhere else. I was like reading about other frameworks and approaches, and was surprised how naturally those approaches would be in Clojure. Like Compose UI, for example, requires a Kotlin backend plugin, so it's like they used to ship a different compiler for Kotlin. Now they like ship it as a plugin for Kotlin compiler, but I imagine it's huge pain in the ass to support and develop and stuff like that. And Svelte, for example, it also requires a pre-processing for JavaScript, right? And in Clojure, it's just macros. Like you can do it in normal Clojure, like parse your code and do smart stuff, and don't even think about it. It's like not anything special, just like regular day. Um, yeah, it's Clojure is actually like that's the moment when you start to feel that Clojure has superpowers.
Mm-hmm. Yeah, and like so one of the things that I found is that like I've been able to start using other just like I've been able to use Spec because it just works with data, and I've been able to use like Meander, and there's a library called Spectre for state management where you kind of like you want to like when you're toggling a checkbox, you're like going into this like nested data structure and just changing this one piece. And Spectre that's one of the things that it tries to do efficiently. And so you can just use these regular Clojure libraries that work with data, and you just get all these benefits. And one of the things that's been kind of disappointing is that like I really didn't want to build state management. Like I finished building like the graphics and events part, and I really wanted to I didn't want to build a state management library. But what I found was that a lot of the ones that were available were basically coupled to React. So like I wasn't using React, so I couldn't use like Reagent and Reframe and Fulcro. Fulcro is actually probably the closest to, I think Fulcro is definitely the closest one to be able to like use directly is like if you want to reuse a state management library. But for the most part, a lot of the UI libraries are, coupled to their specific environments. And so like, I didn't necessarily want to I'd rather just like use an off-the-shelf library. The goal was for me wasn't to like build a UI library just because I wanted to. It was because I wanted to like there's an application that I wanted to build, and like I felt like I couldn't. So, yeah.
All right, and on the topic about rendering performance, we already like covered that. Just before we go any further from it, I had to mention that at some point when I was developing Skia wrapper for JVM, I did a benchmark. Like I draw all the Figma UI, like all the panels and icons and stuff like that in vector, each frame, and it took like 1 millisecond. So it's like it's not a problem. It's never going to be a problem. Like maybe if you do something like inside your UI, something very very dense and special, like draw a million nodes, something like that, then maybe it will become a problem. But like for normal UI that covers like reasonably sized, I don't know, 4K screen, and it just text labels like of reasonable size, it probably will not be a performance problem for you. Component logic might be a problem, but probably not rendering. Yeah.
Yeah, I mean you do want to like there is some benefit to being efficient. There is that like basically it will extend your battery life if you're like can not redraw stuff every frame. And so especially if you're going to have stuff on mobile, and even for like laptops, like it can dramatically reduce battery usage even if it can meet the frame budget, like do it fast enough. There are reasons just saving battery life that are helpful. But yeah, like you said, it does help you. It is really fast, and you can have really fast low latency UIs just by using what Skia does.
Yeah. On the topic of like switching gears a little bit. So at some point you started talking about the state management, and I was reading about your membrane posts, and in the beginning it was all nice and like functional and data oriented, and then at some point you start to build macros and that register global handlers and stuff like that. Aren't those like contradictory?
Yeah, I mean, I think, well, I mean, sort of. So like, I mean, I don't think macros are kind of antithetical to kind of like functional programming. So I think the macro that you're talking about is, so the main one for building UI components with the state management that member provides is called def UI. And what def UI does is it basically, the definition looks like a regular function definition. And that's because it returns just a pure function. And what the macro does is it basically just does a lot of bookkeeping for you, and it helps you build these pure functions. So like going back to what you were saying before is like, there's the view function and the event function, and Membrane helps you build those two functions. Like all the tools in there are basically tailored towards helping you build those two functions. There's a minimal effect system. So it's like you have the user interface takes a raw event and returns returns an intent. So like, let's say you want to add a to-do to a to-do list. There's an effect system that helps you like provide handlers for those effects. So one of the mantras for Membrane is make the common case easy and the complex case possible. And so by default, like when you click on a checkbox, the default behavior is to toggle, whatever the Boolean value state of the, like there's like a Boolean value and you want to toggle that value. So with Membrane, you can define an effect called toggle, and it can toggle that value. And and when you run your user interface, you provide all of your effect handlers. And you can override them when you decide to run it. And so if you decide for testing purposes that you want to you don't want to toggle, or that you want to toggle and do something else, like every time you toggle, you want to log something or keep track of it, keep track of state or how many times it's been toggled. You can override that effect of toggle to be whatever you want. And so when you're saying it's registering this global effect handler, that's just so that, so the default for usually when you run your UI, you're just using all of the globally defined effect handlers, and they're all using namespace keywords. So that helps, your toggle event is hopefully namespaced. So that way, if somebody else is using a toggle event, they're not, they don't clash. And so the default is just to use all the built-in global effect handlers, because that's usually what you want. So that makes the common case easy. But for the complex case where you're doing testing, debugging, something else, something during development, you can create your own effect handlers, and you can use a combination of overrides, and you can also, you have access to the list of all the globally installed effect handlers. So you can say I want all of the globally effect handlers except for the ones with this namespace. I'm gonna instrument those and debug them, or I want to profile just those. So you can say it's easy to make a list of all the effect handlers except for all the ones with this namespace. We're going to time how long they take or how much time we're spending there. And it's easy. So if you're doing that more complicated thing, the default is use all the global stuff. But if you want to do something else, it's really easy to do that. There's it's built-in support for handling that. Going back to the macro that creates the components. There's the post called reusable UI components, and it kind of goes more in depth. But basically for UI components, so one goal is, there's a couple goals for when I was creating the, doing the state management, is that there's no global state, there's no hidden state, and there's no side effects. That's those are kind of the design constraints that I started with, which is different than even with React, if you create a React component, I don't know if anybody's ever tried calling the React component that you made, but I don't know what happens or if it breaks. I've never seen anybody do it. It almost just doesn't make sense. With Membrane, the component is a pure function, and you can call it, and it'll return a value, and you can like, okay, what's my to-do list? You can pass in the state or return a value. You can ask like, okay, what happens if I click here, and it will return an intent with no side effects. You can measure it. You can like see what all the colors are that it would have rendered. You can render it to a you can render it to an image. You can instrument it with spec, where you like throw a bunch of data at it and then write a bunch of images out to see like, you know, what are some random permutations of what this user interface looks like. And so that was kind of the goal. But to make it, you know, make the common case easy is, for the most part, like you have to deal with these. I try to like enumerate the different types of state that you want your components to handle. And so if you have a, I think a really good example is like the, I think if you are building a state management library, even though a lot of platforms have a built-in text input, I think just trying to build that with your state management library is a good exercise, because you have a lot of these different types of state that are important for building user interfaces. You have contextual state, so like focus. Generally, there's like, you have a user interface, and there's one item that has focus, which basically determines which part of the user interface is going to respond to keyboard events. So you should be able to have contextual state, and a lot of times, you should have contextual state. You also have incidental state, which is like, so if you have a text input, most of the time what you care about is just the string, like whatever they typed in, whatever the end result of like all of the keyboard events, you care about that string. And a lot of times you don't care about the cursor, you don't care about the text selection. And for the most part, you don't necessarily even care about the focus. Like you just kind of want that handled. You want all the incidental stuff to just kind of use the defaults. And I think what's interesting about the text input is that, like, is the cursor incidental state? Well, it depends. So like some user interfaces, you really care about where the cursor is. And like, that's not incidental state. It's like, it's essential to like whatever your use case is. And then for other applications, like who cares where that, like, no, just handle the cursor from me. Like when they hit backspace, delete a character and move the cursor back. And so a key aspect from, or the design membrane is like, okay, whether there's this incidental and essential part. And for a lot of cases, it will depend on the use case. And so you should make it easy for to build state where like the component actually just doesn't care, and the user gets to, whoever's using your text input gets to decide which state, if the cursor is incidental or essential to their use case. Like, I think this is something that UI libraries don't necessarily do a good job of. If you look at, there's a library called Recom, which is a bunch of components for reframe. And they have like, they'll have like a calendar widget. And they have like this thing where like, they do deal with that problem where like sometimes for a reusable component, sometimes state is incidental and sometimes it's essential. And so you want to be explicit and sometimes you want it to be implicit. And so like, there's all this extra stuff that they built in utilities to like kind of handle that, because it's not part of the default state management stuff. Like it's not built into Reframe itself. And it's built by some of the people who worked on Reframe. And if you look at the examples for Reframe, like it doesn't necessarily like talk about that or help you do that. So for remembering, what I wanted was, I really wanted to make that easy, is to like make that essential and incidental, being able to provide state that is where, like, I mean, to make it reusable, a lot of times you want like, to be able to have state that is either essential or incidental, depending on who's using it. And so basically the macro, what it does is it does like, it's a macro, and it like will look at your code, and it will it basically just does a bunch of bookkeeping for you for, you know, if you pass in the cursor to a text area, you're making it explicit, and you're basically saying this is essential state. And so use it. And if you don't pass it, it's incidental state. And so it'll kind of like, there's an actual, like, so for every membrane component accepts one map as its argument. And the reason it has to accept a map is there's got to be a place to put this extra state. And that place is, so when you pass the incidental state, it gets kind of like, you know, there's a namespace like incidental key, basically, where all that state will go if it wasn't explicitly passed. So you end up with this thing where like there's no hidden state, and you can actually like, you know, like you can put, like, just similar to reframe, you can put all your state into an atom, and then you can dereference it, and you have that value, and it will, and then you can pass it into your view function, and it'll return the same thing, and it'll like, you know, exactly with the cursor state. So if you've ever had to like, debug a web application where like the cursor was part of the bug, you know, you can't like, even if all of your state is in reframe in this atom, like it's not going to have the cursor state. So you're going to have to like run all the reframe stuff and get into that state, pass in the atom and that value. And then you're going to have to like go find that text input and like set the state, because that state is hidden. And even worse, it may not even be accessible to be at all. Like if you've ever had a bug with Chrome autofill, it's just like, there's just no access to that state. You're just like, it's not a good place to be. And kind of another implementation that I looked at and didn't like was, so React has, so a lot of the stuff like, well, there's React hooks, and there's a React hook called use state, which you can basically, when you're writing a React component, you decide which state is incidental, which state is essential, which is not a good place to be, because it's not whoever's making the component, it's whoever's using it that should be deciding. And so ahead of time, you decide, okay, well, this is going to be incidental, and I put it, you know, and I update the state using this hook, this use state hook. And then what's worse is that state is now hidden. It's like, if you want to get the full state of your application, the view, you know, it's like, you can't, like, it's stuck in this use state, like deep in the tree somewhere, like who knows where they put it. But so the long story is like the macro helps you deal with this contextual state like focus, and is like the divide between the incidental state and the essential state. And it will kind of like wire all that stuff up for you. And it also makes it easier to like, it would probably help. It's kind of hard to show without like a visual example, but like with a checkbox, you know, like let's say you're building a to application and you have a to-do item and it has a field that's complete or not complete. The definition of a checkbox should say like, I want to toggle the complete field of this specific to-do in this specific to-do list. There's basically support for references that lets you define that as part of your checkbox without saying like, but the checkbox, like, it doesn't just work with like to-do items. It also works with like any other nested state. So it's like, it handles all of this wiring up for you. So the checkboxes toggle whatever was passed in. And so if it's like the complete field of a to-do item, or like, let's say you're building applications like, oh, I have two to-do lists. I have like one for my home stuff I'm supposed to do at home, and like I want a separate list for the stuff I'm doing at work. You don't have to change the checkbox to know that like, oh, or you don't have to change you don't even have to change your to-do list UI. You just like make two of them, and it's like kind of I don't know, it's a lot easier to explain with an example, but hopefully that makes, I don't know if that made any sense, but hopefully.
No, it does. Yeah, I've read your blog post probably already in the context, but I think it does explain you. And I also think that the fact that you identified those three types of state, differentiate between them, and it's pretty cool. And also the ability to hook into incidental state is also, I think, important. I can totally feel you, because yeah, sometimes you do care about where your cursor is, or scroll position, for example. Like probably scroll position is more natural example, because most of the time scroll is something that you take for granted. Like you just make a view scrollable and you expect that it will be able to scroll, right? But sometimes, for example, you do implement a markdown editor and you scroll left panel and you have to calculate the scrolling goes right. So in this case, scroll position becomes something you want to control. And it doesn't have to be a different component. It would be better if it would be the same scroll view, I don't know, but you just get control to the scroll positions that it uses. So yeah, absolutely. It's a very good target, I suppose. Do you have something to show? Maybe do you have some flashy demo of Membrane? Because we're talking so much. Maybe do you have something visual to show? No?
Yeah, I think that's a good idea. So we were talking about the, sorry, my keyboard's going to be really loud. I found that out.
That's okay.
But host disabled participant screen sharing. It says Zoom is.
Okay, let me change that. Okay, try now.
Okay, now it's on me to give access. So let's do that.
Yeah, okay. Yeah, I know what you're talking about. Okay.
Okay.
I also found out that my camera seems to be confused by the fact that I'm wearing a blue shirt. So when there's more blue in the frame, it makes everything red, and if I remove it, it makes it normal.
Okay, so it says okay, well, it says I need to quit and reopen, but I'm gonna just try it again anyway. Okay.
You can no.
Okay,
you press later, and it will let you share anyways. Yeah.
Okay, cool. Yeah, I just did that, and that seems fine.
Yeah, it's very strange dialog box, because for many programs it says reopen, but it doesn't actually. It's not needed. For some reason it says it, but it's not needed. Yeah. Okay. I can see your screen, and
okay, it says I'm sharing. Oh, you can see it now.
Yeah, I can see it on stream as well.
Oh, okay, great. All right, so let me check in. I don't know, this is probably too small. So while that's loading, I can maybe, so this is just the to-do demo, which I think the to-do MVC is just like a common way to like show what a user interface looks like. So I'm just going to load this whole file here. And then, so I have these, so this same demo will work with any of the backends, but I'm going to load the Skia backend. And so So here I have a function called delete x, which is actually, it doesn't delete anything. It's just the little x. So I wanted to use really simple UI, really simple like graphics primitives for this example, just to make it easy to follow. But basically, like let's show it. So the way you run a user interface is every backend has a function called run, and you pass it a function that takes no arguments and is basically the view function. Basically, you just pass it the view function. And so if I do that, hopefully it will, here we go. Oh, okay, well, oh yeah, so you can see that
you can see
there's
X.
a red X here.
Yeah.
And so the implementation is above here in the, I wonder if I can move this over here. Okay, so basically it's a, we're talking about the shapes before, but it's basically 2 lines, which is a path of like 2 points. And so, yeah, I mean, it's like, I mean, I think this is like one of the things that UI, yeah, I mean, it's all just functions. So here's the definition for a single to-do item. So I'm just gonna evaluate it, and then I'm just gonna run it just to show what it looks like. And so you can see it's just the to-do item. It's just one item in the list. And you can say like, I need to drink coffee today. And you have a checkbox here, and then you have a delete item, which actually does delete it. So let's look at the definition. There's the delete X, which you can see here. And it has a response to the mouse down event, and it will delete the to-do. And so this $sign here within a def UI will, so I mean, there's more in the post, but basically anything, if you prefix a variable with the $sign, it will make a reference to that, to where that data is, and it can be nested. We'll see that it can be nested in a data structure. So, so the data for this to-do item.
Is it by the way, is it like a pass to this, like pass and get in, something like that?
Yeah, like, so I can actually like, so let's actually just print it out. Hopefully this works. Okay, so, I mean, it doesn't look good, but basically it's just a data description of how it's nested in the in its data. So right now it's just like the key path for the to-do, like right here, is just in the to-do key of this map. And so the reference for that is just a vector with one key path. So I mean, it's basically like get in. There are more types of references, but most of the time it's just like get in, whatever get in would work with. And yeah. Okay. So, and the other thing that you can do is, well, I'll just keep going. So now you have a to-do list. And so basically this is the definition for the to-do list. And we'll run it. So, oops. I still have, well, you can, I mean, you can see the references because when I changed it. So basically it's, yeah. So now we have to-do list of 3 items, and you can see that it still kind of works. the to-do item is reusable, and then the definition is really straightforward. It's just like a vertical layout of all the to-do items. And so like one of the design goals was that like you make complex user interfaces out of simpler user interfaces, and that you can test components in isolation. And like another thing that you can do is so here's an atom with the to-do list state. So instead of passing in a like so you can when you call run UI, you're passing the initial state, and instead of passing in like just the initial state, you can actually pass in the atom, and it will run the user interface with that atom. And so as I change it here, you can like now see, if I look at to-do list state, you can see the updated state. So there's a bunch of gunk here for the incidental state. So I'm just gonna not show that because it's ugly. But basically, you can see the you can see what the model looks like after you've done the state, and you can also this works. So so I should be able to just change the atom. So we'll change the first thing to be true. And so now the UI is true. I don't know if anybody, I don't think we need to see the what the reference looks like anymore. So we can just redefine it. And you know, like I think I mean, for me, like one of the things that attracts me to Clojure is the REPL-driven development. So supporting that was a high priority for me. And so
I also noticed that you the cursor in text box looks kind of strange. So you're doing your own text editing here, right?
Yep. Yeah, the cursor does look kind of strange.
Do you do all the stuff like selections, scrolling inside text box?
Yep. Actually, there's no scrolling inside of the text box, but if you wanted to do that, you probably, yeah, that's not something that's supported right now. But okay. So there's like, yeah, I mean, text editing is kind of a pain. So I think eventually I'd like to, there's kind of two pieces that I haven't worked on yet that I think are interesting is like one, being able to embed, figuring out how to like embed UI components from like some of these more, like if you wanted to embed the text label or text editor from UIKit, kind of figuring out what the best way to do that, maybe and seeing what that looks like, and trying to like, so it's really easy to embed membrane components into other frameworks because it's just like this pure function. I mean, most of these components are like, you have the state and the pure function and then they're coupled together. And so if you want to like make it work inside these other frameworks, you just kind of like write a framework that like puts those two things together. One of the issues with trying to like use other frameworks components is that like these things are coupled together and the pieces are inextricable. So you want to get back these like the pure function and the state separately, but they don't necessarily give you a straightforward way to do that. So trying to figure out, basically trying to find ways to do that so you can like reuse existing, because like, you know, most of the membrane components, if not all of them, are like written by me. So it's like, if I want a scroll view, like I got to make it. So being able to reuse stuff where it makes sense would be nice.
It's also very impressive that you like you have this UI, right? And you can just cut the part of it just single to do and render it with the same machinery, like without changing anything. And then even part of that, like single cross, you can take that and render it as well, and that it does actually compose, right? So you put big UI is built from small UIs, and this is, I think, is a kind of holy grail for UI development, kind of. So yeah.
Yeah. So let me just show this, like one more example with the to-do. So here's the full kind of to-do app. So like one of the things that I'm not sure is that is not sure is a good idea, but I think is interesting is a filter. So the visible to-dos is just a, you just like, so, I mean, like one of the things that like is really annoying is that like, so this to-do item is like part of a like the, it's like a part of a filtered list. I should probably, let me turn back on the, where it was showing the reference. So, so this is one of the more interesting ones where like the reference is actually, the filter is actually part of the reference. And so like a lot of times, like if you've looked at some of the to-do MVCs, it's like, okay, I have a checkbox that's toggling whether this field is complete or not. And so I'll do it for the, so the checkbox is just getting this, this complete like value. And so it's getting this key, and the key is nested inside this data structure of the to-do list. And if you look at some of these to-do MVCs, like you run into stuff where like the checkbox has to know exactly where it's nested, or like what, the data that it receives, it has to know where how that's nested in the like global data structure. And so like one of the cool things here is that there's like, I mean, I can actually look at the, like this is the definition of the checkbox. Is like, that's it. It's these two things. It's like toggle is a logical negation. And then the reference is, this like value that was passed in. And that's like I mean, like, I think logically that is what a checkbox is. So like, I mean, part of this, like one of the goals for this macro is like, okay, I want to like, how do I think about user interfaces? Like if I was just going to define a checkbox, like just on a piece of paper and I was going to communicate it to another person, like as part of like an educational course or something, how would I define it? And it would look a lot like this. So like I try to make it like, here's how I think about it. Here's what it is. And so I try to make the program understand the way I think about it rather than like the other way around. And so, and you also run into this thing that's like, okay, so I have a to-do app, right? And where's the to-do app? Yeah, so I have a to-do app and it's like, okay, I want to add another to-do list. And when you do that, like, since all of these components are like, you have to know how they're, the state they care about is nested more broadly, like it makes it harder to reuse, or you have to like pass in all of these like callback functions so that like, you have to basically change the component to like, if it's going to be reusable or use a different part of the nested state. And let's see, to-do lists. So And you should like one of the goals for the reusable UI components is like, if it's coupled to like where it's nested in the state, like it's not necessarily reusable if you have to like rewrite it to reuse it. So we should be able to use the same exact to-do app. You know, we should be able to go to the next level and say like, okay, there's a to-do app with the to-dos, like, so there's a list for home, and then we'll say there's one for work. It's complaining. So I changed the syntax to use literal maps. I don't know if that was a good idea or not, but anyway, that's why I was confused. And so so we should be able to just
Yeah, I think that this is independence of state. Of course, box shouldn't know about the place it is nested, and that's probably what you want most of the time.
Yeah, hopefully this works. So now there's two lists and to app to. Hey, and now we have two to-do apps. So with two separate lists.
It kind of works, yeah.
Well, what's happening is they're actually, since they're next to each other, like the big long list was pushing it way off.
Yeah.
So it's
cool. Composable UI. Nice.
Yeah. So like if you, I mean, so like basically when you define these components, I try to make it as close as possible to what you would write on the, like if you were going to write this on a whiteboard and say like, here's the UI that I'm building, or if like you got a wireframe from UI designer, like if that it was like very close to, the way you think about it. And a lot of the ways you think about it is like, you have a checkbox and you know that there's implicitly like it's going to toggle this value in this nested state. So I try to make that work the way you would expect. And these are all pure functions. So it's like if you want to reuse these components in other places or use testing, debugging, instrumentation, it's a lot easier just because it's like, so I can call so like it returns a bunch of gunk, but basically it returns a value. And you can also just like see what it would look like without all the event stuff. So like here's the same thing, but like here I'm doing it without all the event functions. So it's like it's not hooked up. So you don't have this stuff where like, okay, when I click delete and I'm just like want to look at it, or I want to like make mockups with it, or I want to like, like build something. It's like, okay, I can separate out the view function from the event function. And it's like, and you can also, there's a draw to image function,
nice.
which takes like, and then it just takes the element. So because this is just a value, I can just, hopefully this will do something. And like, okay, so now I just have like a picture of the state. And if I wanted to like programmatically, if I wanted to use spec to like one of the things that I'm like in the process of working on is like having components also spec the data that they require. And then you can do stuff like, like if you spec the data it requires, you can drive it using the generative testing, and you can just have it spit out all the versions of the UI that might happen, and be like, okay, that looks wrong. So like, and like try to find bugs that way, and also specking the, you have the event function, which takes like mouse and keyboard events. And basically you can, if you spec the raw mouse and keyboard events, which are really just like regular data, you can then exercise the event function. So like, let me show an example of that. So I have the to-do item here. And you can do, so mouse down is typically like an event that triggers, like you fire the event and like stuff happening, everything's connected, you can fire the event and like everything's, like it's going to start sending network requests and putting stuff in the database. Whereas here, I don't know actually. Here, let's so we're just gonna see if we can just like find the first mouse input that that will actually do anything. So X and Y, we're gonna find the first mouse input that that returns an intent. So for X range 200, Y range 200, X, Y. Okay, so, and it's, so let's see what the value is. Okay, oops.
Yeah, it would be trickier to see what value is. Yeah. You should do when mouse move X, Y, yeah, and result, yeah.
Okay, so at 0.55, and you could also like one thing that I think would be cool is like you can build tools around this. It's like you get your user interface, and you can just like paint the screen with all of the interactive parts based off the mouse events. You can, I don't know, there's like a lot of opportunity to build tools on top of this because it's all, you can just use all the same closure testing tools and data generation tools like Spec and Mali, and I don't know.
Yeah, absolutely. I think when React hype started and when React came to ClojureScript, and somebody, I'm not sure who, probably started, maybe not starting doing hiccup for UI, like hiccup when it's a vector of div and some properties. I was thinking, okay, now we can like write test for UI, like, and check if div that you wanted is actually generated, because it's just data, but it wasn't really just data. It was like converted to React components under the hood, and then I've never saw somebody do anything like that. So unfortunately, yeah, but this looks legit. Yeah, looks useful.
Yeah.
Cool.
Like I don't know if you want to see more examples, or does this work?
Do you have different backends, maybe?
Yeah, so I think one of the cool ones is the mobile backend. Like I think that's one of the areas where so right now, still today, if you wanted to build a web UI, I would not recommend Membrane, because I haven't really focused on the web, because there are really good options there. Like I know I've been beating up on Reframe and Fulcro, and but these are actually really good options if you want to build a web UI today. Use those; they're great. The people behind them are really smart, and they're also really helpful. Like they've both taken time to talk to me. And if you go like in the Clojurian Slack and ask questions, there's people there that'll like, help you. I don't know, like they're really great. If you want to build them today, those are really great options. I think people are interested in mobile because currently today, there's not a lot of great options for, especially in Clojure. And even if you look at like, kind of what people are just trying all sorts of things to try to make it work on mobile. And I can't tell if like, there's a lot of churn there. And I don't know if that's like just the way it is, or if people are kind of unhappy with the options that are available. Like people have tried like, oh yeah, we tried using the web stuff. And then like, for whatever reason, then they switched to React Native. And then they're like, okay, we don't like React Native. And so we're going to do like, build a separate app for each one. So like, yeah, this is so with QuickTime, you can like mirror your phone. So this is like just mirroring what my phone looks like. Mm-hmm. And I have this test Skia app, which all it does is it basically, you can see, or maybe you can't, it's kind of small, is that there's yeah. There's an IP address there, so we can CIDR connect. And you can actually, you can like run the REPL just on the on the wild internet.
How does it run? Is it running JVM on the phone?
So this is this is using GraalVM's native image. So basically, what it does is
GraalVM cannot do REPL,
right? So it can't do so Clojure has a val, and the way Clojure's JVM eval works is it spits out like JVM bytecode, but there's no, when you compile it to native image, there's no JVM available. It's like compiled ahead of time. But this uses Borkdude's SciREPL. So it interprets, so there's a Clojure interpreter called
I know. Yeah.
Sci, and there's a REPL there. So
okay. Cool.
So like, so here's the same thing. It's like really bad on mobile because obviously like everything's really small.
Can you type? Do you have keyboard?
One version I had would let you type, but I guess okay. Well, yeah. So there's a function that brings up the keyboard, and I had it working at some point. Unfortunately, this version does not have it. But yes, you can bring up the keyboard, and it does work. It's just
okay.
I guess maybe it's not set up on. It's not set up with the SciREPL. Oh yeah, because okay, yeah. But anyway, I think like another cool example is so I really like the examples for work on mobile. Oh, it's okay. So the REPL on the phone actually works really well, but Emacs gets confused when you switch REPLs or whatever, when you switch projects using CIDR Connect. So I'm just going to restart the app here.
Okay.
Yeah, it actually works really great on the phone. The stuff on the phone works great. It's just Emacs gets confused.
So wait, so GraalVM native image is it has membrane and a Sci, but the application code that you actually run, you upload it through REPL. So like all your dev UI stuff is actually run through SCI, right?
Mm-hmm.
Okay. That's cool.
Yeah. So I mean, it's basically a testament to like how good Sci is, and that it can like almost all this code just kind of works. So here's the game of life And it has like multi-touch, so you can like
Hmm.
add cells. I don't know if you've seen the Game of Life.
Yeah, of course.
So
Cool.
um,
Nice.
yeah. Okay.
Cool.
It
Okay.
was really hard.
Yeah.
Yeah. Anyway, yeah, it was really hard to find good examples of like the UI stuff in Clojure because almost all this stuff is web stuff, which you like, which for the most part was like hard to, like a lot of that stuff is important because it's all based off HTML. So it's like, but I did like one other example is the Ant Simulator, which is like a really old demo that uses refs. So like that was like, yeah, it was really hard to find good demos that were already pre-built. But I'm hoping like, I mean, I think like I hope that I mean, I think sometimes for problem solving, solving a more general problem is easier than solving a specific problem. And so I think solving like building your UI with like primitives like shapes, rectangles, and images, and like 2D geometric shapes is easier than building it like trying to figure out how to make HTML usable, even though like one is like maybe a more broad problem. So I hope that
I
I'm really
agree.
excited for your project, and I'm excited to see what you do. And I hope that I can like reuse a bunch of it. But yeah, I don't know. Like, do you have any other thoughts about like kind of the direction that you're planning on going, or where you're at with your project?
Yeah, well, first of all, I totally agree that sometimes programming in web and HTML is like you just banging your head because like you want to do stupidly simple thing, and it's harder to do than it would be like from scratch by drawing everything yourself. Like it's sometimes there's like tiny gap under the image or something is not positioned correctly and you're like, oh, what's going on? Let me just provide every coordinate that you need and I can calculate them myself. It will be much simpler. And about directions I'm going to take, I got good inspiration from previous stream and from Zion from reading Membrane. I had a few great insights. I think like at least the directions and the goals that you set are excellent, and I will try to match them as much as possible. I'm a little bit more concerned about the performance and partial updates maybe. So like update only the part of the UI that is actually changing. Being able to do that, and so it probably means that you will have to have object model somewhere that you synchronize with your data. Like you produce HTML, you produce description as data, and then under the hood somewhere there's actually records and objects that store like position, sizes, maybe cache some text layout, stuff like that, which are transparent to you, invisible to you even maybe. But they do cache that stuff so that you can go inside the tree and point at something and say re-render this, and it will only re-render that. The other thing that I'm thinking that there are probably at least two layers, maybe three layers of stuff, how you can organize that. And the deep level, it's like kind of DOM level when you have your mutable object-oriented objects that cache stuff and draw and measure themselves, stuff like that. And it doesn't have to be convenient to use, but it has to be there. And then on top of that, you build some nice like React virtual DOM maybe, or something else library. And maybe on top of that, you build like state management, subscriptions and stuff like that. I feel like it's higher level, and I would probably not want to bring it to the basic stuff or decide for users even. So I think I feel like state management is something that people using might want to change. Sometimes, like most of the times, yeah, one global atom is okay, but sometimes you maybe want something different, or you want multiple sources maybe. That's my ideas. So,
yeah, I mean, memory does provide, the state management stuff, but if you like, there are examples using reframe and fulcro. I don't think you get the full power of those because they really enjoy using React. But yeah, I totally agree with you that like being able to like choose the state management library that makes sense for you. That's why like all of the backends have a run function that takes the view function, and you can produce that however you want. So like if you want to use membranes state stuff, or you want to like build your own or use a different thing, they're separate. Like there's one thing that deals with kind of the graphics and events, and then there's another part that does the state management, and they're orthogonal. You can make independent choices, and I think that's a good thing. Yeah, and I think like membrane, there's a lot of like, I still think that like I really hope that you take I'm hope that you take an approach that is like has a lot of data and a lot of pure functions at the bottom. And I think membrane tries to embody that, but I think there's a ton of different design decisions that I either took because they were familiar to me or because that's what the first thing that I thought of. But I think there's a lot of different directions that are unexplored. There's a lot of really cool stuff people can do. And I think more people I hope more people look at this and try to figure out how to build UI kind of in this more functional design, because I don't know if I've done it the right way or not. And I'm more interested in like being able to build cool stuff. So if somebody comes along and does it better, I think that's awesome. So can't wait to try whatever you come up with.
Yeah, I agree. I guess the more there is, everybody wins in the end, and hopefully, if I do it correctly, I will have a layer of widgets, like low-level widgets that could be reused, like text input button, checkboxes, stuff like that. I mean, this feels like a stuff that, like, I'm planning to do my own drawing of those, and event handling, but then probably once it's done, you very rarely want to roll out your own. Like I plan to make it possible, but probably you don't want your own text input, right? Most of the times, at least.
Yeah.
And hopefully it will be like I also like I am a big fan of reuse and components reuse, especially, and how like an abstractions, like so you can make stuff actually reusable, like, and you can bring it in different framework. It's probably ultimate reuse test, right? And yeah, and I think if you have that goal, it makes application overall better as well. So yeah, we'll see.
Cool.
We'll see. Yeah, probably we'll exchange some implementation details or something.
Yeah. Cool.
Okay, thank you for coming. It's been 2 hours already, but it's been super fun, and yeah, I learned a lot. And your demos are like verify. Yeah, it's great to see like such a nice composable UI and like power of Clojure in the REPL and stuff like that, mobile. So yeah.
Very cool. Thanks for having me.